In this video, we're going to discuss how to calculate slope. Slope refers to the angle or direction that a line is traveling. So the slope tells us if the line is going up or down. It tells us if the line is steep or shallow. So slope is actually talking about the same concept that we worked with in the last unit, but in the last unit we normally called it rate of change. But slope is the exact same idea. We use the letter M in math to represent slope. Some people say that's because the French word for climb is monter. I'm not sure if that's true. In any event, slope is defined as rise over run. So rise is the vertical distance that the line travels, while run is the horizontal distance. So rise is vertical, run is horizontal. So your vertical distance is how much is y changing? How much are we going up or down on the y-axis? And the change in x is telling us run. So it's really the same thing as rate of change. We're looking at the change in the dependent variable divided by the change in the independent variable. But we're going to now call that slope, and we're going to use these concepts of rise and run. I only need to find 2 points on any line to then calculate the slope. So in this case, what I want to find out is as I look from left to right, what is going to be my rise over run of this line? So this line, to travel from the first point to the second point, I have a rise of 2. The change on the y-axis is going to be going up by 2. So my slope is going to have a 2 in the numerator. And then I'm always going left to right. So I'm going to go 3 over. That's my horizontal distance. So my slope is 2 over 3. So if I have a positive slope, that means my line is going up as we look from left to right. So I've got a slope here of 2 over 3. Let's just look at a couple more examples. Again, I only need 2 points to define the slope. So you want to try to find 2 points. In this case, again, as I go from left to right, to get from the first point to the second point, my change in the y variable is just 1. So I have a rise of 1. I'm going from 2 to 3. And then I'm traveling 4 over. So rise can be positive or negative. I like to think of run as always being positive. We're always going left to right. So my slope is vertical change, rise, divided by my change in x. My horizontal movement is 1 over 4. So again, I've got rise over run, and it's positive because the line is going up. In our next example, we're going to start working. You can see that this line goes down. We read lines just like we read English, from left to right. Again, I can find any 2 points to calculate the slope. Why don't I pick those 2? And I'm going, again, to calculate my rise and my run as I go from left to right. So as I go from the first point to the second point, I'm going down 1, 2, 3, 4, 5, 6. So I've got negative 6. And then I'm going over 1, 2, 3, 4, 5, 6, 7, 8. So you kind of can think of those little slope triangle where I've got a run of 8 and I have a rise of negative 6. And it's always rise over run, and we always want to leave this in lowest terms. So out of negative 3 over 4. So again, you can always check if you've calculated a slope and your line is negative, it should be going down from left to right. Let's look at just one more example. Again, I can pick any 2 points to calculate the slope. And I can think of my rise here, I'm going down by 2. And my run, I'm going only 1 over. So my slope would be negative 2 over 1. Or we could just call that negative 2 as well. Sometimes we like leaving it in a fractional form. The fractions are really helpful because it tells us exactly how much I need to go up or down, and then how much I move from left to right. So that slope, it's the same as rate of change. It's always defined as change in y divided by the change in x. And what we're going to work on next is how can I calculate the slope if I didn't have a graph or I didn't want to sketch a graph. And this is helpful if the numbers are big, if we have decimals, if we don't have graph paper. We want to find a precise formula to help us calculate the slope. And we're going to use this same concept, the change in y divided by the change in x. So the slope formula, again, we know that slope is defined as the change in y divided by the change in x. And really the change in y is just the difference between the two y coordinates. So if I have any 2 points, the difference between them we could call is y of the second point subtracting y of the first point. That's going to give me how much is y changing. And similarly, the horizontal distance, or the change in x, is the x coordinate of one point subtracting the x coordinate of the second point. So y2 minus y1 divided by x2 minus x1 is my formula for slope. When I have small numbers at the bottom of a variable, we call this a subscript, and those are just labels or names. So I'm calling my coordinate y2, so it doesn't mean squared. Squared would be a superscript above. It's just a label. So let's try to find the slope between, let's say, 3, 8, and 6, 13. So I've got 2 points. I don't want to graph the line, but let's see if I can find the slope. And what we're going to do first is I'm going to label these coordinates. So here's my first point. So I've got x1 and I have y1. And then here's my second point. So I can call that x2 and y2. I'm just labeling each coordinate. It doesn't matter which point I want to call the first point and which point I want to call the second point. I would actually find the same slope if I reverse these, and you can try that on your own to test it. And now all we need to do is plug in our values into our slope formula. So our slope formula, y2 minus y1 over x2 minus x1. So y2 I can replace with 13. And then I can subtract y1, which I will replace with 8. So the difference between my y coordinates and my change is y is 13 minus 8. And then similarly, x2 was 6, and x1 was 3. So I'm just plugging in my data into my formula, and now I can evaluate and reduce. So my slope in this case would be 5 over 3. So if I plotted these 2 points on Desmos or on a Cartesian plane, I would have a rise of 5 and a run of 3, and because it's positive, the line is going up. I'd just like to do one more example, just to throw in a couple of negatives, just to make this a little bit trickier and to show you why we need to be careful as we substitute. So let's try to find the slope between -2, 5 and, let's say, 0 and -7. So again, I want to start by labeling all my coordinates, x1 and y1 for my first point, and x2 and y2. And now I can calculate the rise and the run by subtracting. So again, I'm going to start with my slope formula. I like writing down the formula as the first step of the question. It helps me stay organized. It helps me know exactly what I'm substituting. So y2 in this case is -7. I'm subtracting y1, which is 5. And then x2 is 0, and I'm subtracting -2. So be really careful with all of our negative signs. So -7 take away 5 is -12. 0 take away -2 is the same as 0 plus 2. So I have 2. And then I want to reduce this. So my slope would be -6 over 1, or just -6. So if I was going to, again, plot this line, I would be going down 6 units for every 1 unit I move to the right. So we can calculate slope still with that concept of rise over run by using our slope formula even when we don't have a graph. So I think your homework today and your quiz is really going to lean heavily on calculating slope, either when you're given a graph or when you're just given any 2 points that exist on the line. Okay, shoot me an email if you have any questions, and that's all for now.